Hello everybody, we're going to continue our discussion with arrays, and I thought I would put some of the topics that I'd like to talk about today as much as I can in 15 minutes. So let's just jump right in. The first thing, I want to continue talking about arrays, and this is pretty straightforward, letting the user specify the size of an array. You know, if you've worked with the scanner class, this should be straightforward. So we're going to go ahead and import scanner, and we'll create an instance called keyboard. I'll ask, how many students are there? And students is going to be our array. Int num equals keyboard dot next int, and we'll create a string array called students equals new string, passing our integer called num. And that you could run this 10 times and get a different number of elements in the array each time. So just to demonstrate that, we'll print out students dot length, and it'll say there are however many elements in the array. And so if I run this, how many students are there? 5 elements in the array. 100, there are 100 elements in the array. 1,000, you get the idea. The next concept is to reassign array references. When one moment here. Okay, I'm looking at my notes here. When we have an array, let's just say int called numbers, and we'll do the shorthand, initializer. Okay, let's just go all the way up to 10 here. And so we could see that our numbers array has 10 elements in it. Let's just go ahead and do a shorthand for int x in numbers. Go ahead and do our shorthand for loop, and you can see that it prints out. There are 5 students in that array, but here it prints out all of our values here. Now let's see. So this is stuff we've covered. Now if we're going to reassign numbers equals new int, let's just condense it down into 5 elements, and after that let's print it out again. Let's print out that same numbers array, and again you see that the data is lost. That's a bad thing. So let me I'll just leave that in there for now. So anytime you have an array and you think, oh, I can just reassign it. That's what reassigning array references. This numbers is our reference to the array. You reassign it and you lose its data, and that's a bad thing anytime you lose data. So this is the bad. Do not do this. Instead, the correct way would be to copy an array, which comes down here. And when you copy an array, what you're doing is you're creating a new instance of an array, and you're going into the array and copying the values out. So to do that is a pretty simple loop, and write it, you'll see what I mean by that. If I say int first array, and we put some numbers in it, 1, 2, 1, 2, 3, 4, 5. Matter of fact, just to keep it, we'll just 6, 7, 8, 9, 10, just to keep it similar to the last example. Don't forget my braces. And int second array, and we'll make a for loop. Int I equal to 0, I less than first array dot length I plus plus. Now, if we're going to copy every element, that's why I'm going to assign it to the length value if I'm going to copy every single one, in which case we need to go ahead and assign new int with 10 elements here. And we will say second array sub I is assigned to first array sub I. And you could see now we don't lose the data in first and second array. Again, we'll do a shorthand for int I in first array make a nice big cap so you can see first array, and I'll copy that and paste it just so you could see that the first array is still going to have its information, and it's going to copy it into the second. Again, do that demonstration. So here's in our first array still has the data, and our second array has the data. We don't lose any information here, so we copy the values out. To match the example from above, if I just wanted to say second array only has 5 elements, and then we would only loop through second array dot length, so we were only looping 5 times. Copy and paste that. Actually, no, we don't need to copy that at all. So go ahead and run that. First array would have 10 elements, the second array would just hold the first 5 of that. So you can get an idea on how to do a copy an array. Next concept here is passing arrays as arguments, in which case we need another method. So we need to go outside of the main method here and write another method. So let's write a method header outside of main, but still inside of the class file so that it works and compiles. It's going to be a public. We're going to call it static because it's going to need to be, we're going to call it inside of a static main. We're going to write this as static, a public static method. It's not going to return anything. We're going to call it show array. We're going to do accept an integer called my numbers, and we'll just go ahead and do a shorthand for loop, and I in my numbers, system out print line I. Just to make sure, system out print line, just so you can get the show array method, just so you could see, kind of in this ongoing output that I'm demonstrating. This is when this happens, we're in the show array method, and we're going to print out the numbers there. And to pass an array as argument, well, we already have plenty arrays to choose from. We'll just choose our second array, which is 1, 2, 3, 4, 5, as demonstrated here. So we're just going to call show array and pass it the value of second array. So when you declare the method, declaring a method that accepts an array, and this line right here calls the method and passes an array identifier, sorry about that, an array identifier um, as an argument. There we go. So demonstrate this works. Now we're calling the show array method, and you can see that the array does get passed and it does print out all of the values. Now, one important, very, very important concept is that when you pass an array, it passes by reference. So big notes, arrays pass by reference, and that means if you make any changes to that array, second array inside of main, you pass it into this show array method and you call it my numbers, similar to an alias. So up here it's called second array, down here it's called my numbers, so just an alias for one another. If we were to make any changes, right, so we already know this show array method worked. Now let's go ahead and make a change. Let's say my numbers. Now let's just change the last element, sub 4, my number's sub 4, and let's just change it to 44. Okay, so you could see that inside of this show array method, we change my number sub 4. Now after here, system out print line, the last number in the second array. Okay, just to demonstrate that we changed it inside of the method, and it's going to reflect that back in main, inside of the main method, which will say numbers sub 4. So again, just big nice capital letters to demonstrate what's going on. And so this is a demonstration of passing by reference and numbers sub, oh, no wonder, second array. That's a typo there. It's called second array up here. It's called my numbers down here. The numbers array was something else way up top. That's why that actually printed out 0. But no, we call it second array here. And so, just to demonstrate that again, you can see the show array method 1, 2, 3, 4, 5, just like we already demonstrated. And then back in the main method, we print out second array sub 4, and you can see that the change has been reflected. So that is an important idea or important theory concept to grasp when you're passing arrays. Last concept here is comparing arrays. Just to determine, comparing them, what I mean is to determine if they are equal. Now, we already have some arrays up top, first array and second array. And let's just change them both to be 10, right? So they both have 10 elements in them. So, and we copied them, so you could say that yes, they should be equal. The way you might think to copy array is something, or to determine if they're equal, you might have something like if, and again I gotta look at my first array double equals second array. Do something. But what this actually does, this right here, this comparison is a shallow comparison, and really what it does is it checks to the memory address, aka checks the address in RAM. to see if they're equal. Well, they're going to be at two different addresses, so they're never going to be equal. And so you should see they aren't equal. And then here I'll say they are equal. And so, you know, the idea is that you would think they are equal because they have the same number of elements and they have the same values. And I believe the output here is going to be they aren't equal. And there you can see they aren't equal, even though they have the same number of elements and the same values. So this is aka bad, right? So the correct way to determine if they are equal is to just write some logic, and you're going to use a loop, and you're going to use some conditional like an if statement. And so we might say, we might create a Boolean variable, and we're going to call this arrays equal, and we're going to set that to true by starting it. So we're going to assume they're true, and only by using some programming logic we'll prove that they're false if they're false. We're going to start a counter off at 0, and the first thing we'll check to see if the number of elements are the same, right? So if two arrays are equal, they have to have the same elements. So first array dot length, and does not equal, right? So if the first array doesn't have the same number of elements as the second array, we set it to false. And so that's kind of the first step. Do the arrays have the same number of elements? It's kind of step number 1. Then we need to determine if they do, you know, we're going to determine, are the elements storing the same values for each position. Meaning, does position 1 equal position 1, position 2 equal position 2, etc., etc. Not forgetting position 0. So we'll say while the arrays are still equal, right? So if this is set to false, this while will be false. While the arrays are still equal, and we're going to loop through each one of the elements. So starting off at 0, which is I, while I is less than the length of the second array or the first array. So we'll say first array dot length. And then inside of our while loop, we say if first array sub I is not equal to second array sub I. So if the array elements don't equal one another, then we set the arrays equal to false. And then regardless, we increment I, so we don't have an infinite loop. And then that should help us. This is the correct way to determine if two arrays hold the same values, right? This is done, if this was a shallow comparison up here, this was a shallow comparison, which we said was bad. This example here is a deep comparison, aka good. It actually goes in and determines if things are equal. And then we can use our flag, which is arrays equal. If they are equal, that's true. Matter of fact, oh well, just type this out. Yes, they are equal. Else, no, they aren't equal. And run that. Now they're not equal y, right? So going up top here, 1, 2, 3, 4, 5, 6, 7, 8, 10. 1, 2, 3, 4, 5, 10. I'm going to pause and pick this up in the next video. So I was expecting them to say, yes, they are equal. However, the last example, of course, failed. So I'll pick this up in the next video. If you're interested to see why this failed, check out the next video. Thanks.